In a previous video, I explained how to integrate the function ln of x and what's the method that we can use in order to integrate this function. Now in this video, I want to explain how we could derive the function ln of x. So if you look in any formula sheet or whatever, you'll find that the derivative, so here that would be y prime, of the function ln of x is actually 1 over x. But I want to explain how we got to this 1 over x. And for that, what we need to actually do is use the inverse function. So we know that this ln function is basically the inverse function of e to the power of x. And we know here that if we apply the function whereby its argument is the inverse function of that function of x, we will get the argument back, which is our x. So here, what we're going to do here is I'm going to rewrite my expression y is equal to ln of x. And to both sides of this equation, I will raise as a power to my base e. And so what I will have is e to the power of y going to be equal to e to the power of ln of x. Now, using our method or our principle that I just explained, e to the power of y is just going to be equal to x. And now I'm going to apply my derivative in respect to x to both sides of the equation. And in a previous video, I also explained how we can do the implicit differentiation. And that's what we have here when we're talking about the function e to the power of y. So differentiating that, we would have to differentiate e to the power of y, which is also e to the power of y. But now we multiply it, according to the chain rule, with the derivative of y. And the derivative of y here is basically dy dx. And now the right side of the equation, the derivative of x, using the power rule, we will get to 1. The derivative of x alone is just 1.
If you got any unsolved problem in the world of numbers and equations, make sure to comment it down below and we can get it solved.
So now what we need to find here in the question is dy dx. And that's what we have here if we look at our equation. So all we need to do here is have dy dx on one side of the equation. And in order to do that, I'll have to move this e to the power of y to the other side of the equation. So here, I will have dy dx using basic algebra is equal to 1 over e to the power of y. That's what my derivative is equal to. But that's not what I want. I want 1 over x. Now, if you remember, this e to the power of y here is equal to x. And I get that from this equation right here. The equation that I got when I basically raised both sides of the function as a power to the base e. And so therefore, I can substitute for e to the power of y just x. And therefore, I will have dy dx is just equal to 1 over x. And that here is my final answer. And that's how I get my derivative of the function ln of x.
Don't forget to subscribe to Sam's Education channel and hit the notifications bell to receive regular updates and access to a variety of solved exercises. See you in the next video.